Hi class, so in this video I'm going to review with you the post-lab questions from Density is a Periodic Property Lab. So, in the first question it says, complete the data table, calculate both the mass, initial mass minus final mass, and volume, final volume minus initial volume, for each sample 1 to 3 for all three elements, silicon, tin, and lead. Record these results in the data table. So you have your data table and it should be filled out. Remember, we ignored this part because we didn't do the lab that way. I had you use weighing dishes and then having you tearing, T-A-R-E, tearing the balances so that they would say 0. So you should have some data that looks like this. You have the masses, 9 masses. You have 9 initial volumes and 9 final volumes. This data comes from the review sheet for the quiz on Monday. So what this is saying is, well, you need to subtract the masses from this question, so you can ignore that part right there. But you do need to do this one, the final minus initial. So on another sheet of paper, you should be showing the work on how you did this. So 16.0 milliliters minus 14.8 milliliters to get 1.2 milliliters. So you should be showing at least once how you do the calculations. And then to do one more, 17.4 milliliters minus 16.0 milliliters. Again, I'm doing those numbers right there. And that gets me 1.4 milliliters. So showing how to do the calculations is really important on your own paper. So that's how you do number 1. In number 2, it says, using the mass and volume data, calculate the density of each sample, 1 to 3, for all three elements. Construct a results table to summarize the results. Note the density of a solid is usually recorded in grams per centimeter cubed. So you see those units are indicated here at the top of the table. Again, this data table is from your review sheet. You can see there's silicon, tin, and lead down the side. So the way you calculate density, you take the mass and divide by the volume. Again, you need to show at least one example on your own paper. So on this one, I'm going to show how you take 2.72 and divide by 1.2. 2.72 grams divided by 1.2 centimeters cubed. On my graduated syllabus it said milliliters, but 1 milliliter is equal to 1 centimeter cubed. So then you do that calculation and you get your answer, which is shown here to be 2.3 grams per centimeter cubed. You round it to 1 decimal place. And you have to do this calculation 9 times. You don't have to write it 9 times, but you do have to show it at least once on your own paper. Number 3 says, calculate the average value, mean, of the density calculations 1 to 3 for each element, silicon, tin, and lead. Record all results in the results table. Use the range of density values for each element to estimate plus or minus. Error for each average. So then they give you an example there. How you calculate an average is, you take these 3 numbers, all for silicon, and add them together. 2.3 gram per centimeter cubed plus 2.1 gram per centimeter cubed plus 2.2 grams per centimeter cubed, and then you divide all of those by 3 and you get 2.2. Now you have to figure out how to do this plus or minus. Now you notice from 2.2 the lowest value is 2.1, so it would be subtracting 0.1. And if you notice to go from 2.2 to 2.3, it's going up 0.1. So you notice it would be plus or minus 0.1 grams per centimeter cubed. If the increase or the decrease is larger, you got to put that larger value here as your uncertainty or your plus or minus value. So you have to do this calculation 3 times because there's 3 averages. Then on number 4 it says, on a graph, plot the period number of SI, SN, and PB on the x-axis versus the average density of each element on the y-axis. Using a ruler or straight edge, draw a best fit straight line through the data points. Use this best fit straight line to predict the density of germanium. So you gotta look at a periodic table. So you see here that silicon is in period 3, tin is in period 5, and PB is in period 6, which means that GE is this missing element in between, right? This is exactly how Mendeleev figured out what the properties were of missing elements. So we have to graph period 3, 4, 5, and 6 on your graph. 3, 4, 5, and 6, and you write period number here, and you put density on the y-axis. So whatever your maximum density value is, you would make sure that it fits within these lines. If we look at this data table here, we'd notice that the tin value is 7.2 plus or minus 0.2. I know that because I've done the review sheet already. And so it's 2, 7, and 10. So if you've done the review sheet, you've seen this part of the video where we label the y-axis like this and then graph it. We've got to make sure we have our units on the y-axis. Okay? And then you get a straight line of some kind. And so if there's dots here, you would draw a straight line somehow connecting those points in the best way possible, in the best fit way, and you would see what the density was of the element in the 4th period by going up to that point and then across to the y-axis to get the density. And that would be your predicted value right there, predicted for germanium, which is in the 4th period on the periodic table. Which leads us to our last question. Number 5. Look up the actual density of germanium in a reference source and calculate the percent error between the predicted and actual values. So once you look up the value on the internet for the density of germanium, you put that value right there, because that would be the actual. These two predicteds are coming from your graph. Remember, there should be an absolute value sign at the top, so you always get a positive answer. And then you should always multiply by 100, which means move the decimal place 2 places to the right. And then you get your answer, which is a percentage, because you're solving for a percent error. I hope that helps you answer the post-lab questions. If you have any questions, please ask. Thanks. Bye.